I'm going to show you guys how to use ANSYS to model a problem like this using link element, which is the simplest type of element, 1D element. But before doing this, let me explain this problem and do that manually, doing this problem by hand. And then we do that problem with ANSYS and show you guys that we're going to get same numbers. Alright, so this problem we have a rod. It has two pieces. At first, it's made of aluminum. Cross-section area is 0.1 inches. The first portion going from A to B, and then going from B to C, cross-section area changes to 0.15 inch squared. The length of first portion is 10 inches, the second portion is 12 inches. As I said, it's made of aluminum, and our objective is to find the reactions at point A and point C. So let me first do the FBD. So yeah, okay, we're gonna have a reaction here. I'm gonna call it RA, and then here I'm gonna have a reaction. I'm gonna call it RC. So first force segment is under this load RA. If I consider breaking into two segments, and the other segment is gonna be under load, the thicker one. The second one is thicker, so let me draw it thicker. The second portion is gonna be RC. Alright, so from equilibrium, all we know is summation of forces in x direction must be 0. So RA plus RC should equal 1,000 pound force. This is all we got from equilibrium and from statics. So to solve this, we need another equation from compatibility, looking at the constraints. So look at this, a rod is bounded, is like fixed between two walls. We know that the length of this rod, this composite rod, before and after, not composite, this this rod, it's changing geometry to a step rod. Its length is not going to change before and after. So what does that mean? After you apply this 1,000 pound force, before and after, the length from A to C is going to stay 22 inches. So what does that mean is this, that changing the length of rod AB plus changing the length of rod BC, right? These two should add up to 0. So the first is going to be RA times 10 divided by multiple elasticity. Area of first segment is 0.1. And the second one, RC times 12 divided by multiple elasticity times 15 equals to 0. So let me see. Okay, so E is going to cancel. And what I'm going to have is this. RA plus RC, should be equal to 1,000. RA plus RC. RA plus RC plus 1,000. Both are, all of them going to be added up to 0. So that 1,000 is going to go on the other side. So let me make it cleaner here. So RA plus RC should equal 1,000 pound. And then from the second equation, if we simplify this, I've got 100 RA, and then this 12 divided by 0.15 is going to be 80 RC equals 0. Okay, to solve this, I multiply first equation by 100, add it to the second equation. I'm going to have 180 times RC equals negative 100,000. Then RC is going to come out 100,000 divided by 180, negative. So I'm going to get 100,000 divided by 180 will be negative 555.6 pound, and then RA, which is the left one, is going to be negative 1000 minus 555.6, which is going to give me negative 444.4. Is that right? Let's double check that. I think I need to multiply this by 10. And then, yeah, if I change the sign on this guy, minus 1000. This is the answer. So negative 444.4 pounds. Alright, so let's summarize the solution. What we obtained. So what this tells me that we found both are negative, so against what we had assumed at the beginning. So RA I was assuming is going to the right. Technically it's going to go to the left, RA, and it's going to be 444.4 pounds. And then on the right side, I assume it's going to the right, but it's going to go to the left. 555.6 pounds. And then I had that external force acting in the middle, going 1,000 pounds going to the right. So this is our solution manually. So now I'm going to show you guys how we can model this using link element in ANSYS APDL. Alright, and hopefully we'll have our results matching. Alright, so let's open ANSYS. We need to go here. Alright. my.gbsu.edu. And then go log in to our virtual lab. Alright, so we have to wait until we log in. Alright. Okay, it's coming. Okay, so let me make this full screen. And lab applications, engineering. So APDL, we're gonna run this application. Okay. So this is our work, APDL environment. So go preferences. We are gonna do structural analysis. Okay, you pick that. Or pre-processing. Okay, first thing we need to tell ANSYS that we are gonna use link element. So add. So link element is the most basic one. We are gonna use later the other types of elements. See the level of complexity increases, but I'm gonna use link element and OK, and then I close it. So you see it's there now. We're gonna use that active element types. Then material property. Our material was made of aluminum, so let's go here. For material, you go to material property, material model, structural, linear material, elastic, isotropic. Alright, so then here our modulus of elasticity was 10,000 KSI. 10,000 KSI, but I want to have my units in PSI, which is a standard unit. So I add other 3 zeros, and the second one, this guy is Poisson ratio. I'm not gonna need this for this model, so I just put 0. Alright, so one thing you guys notice is that APDL is unitless. So you guys have to take care of your units. Keep track of your units. So whatever unit you use your properties, your geometry, then your output is going to be based on what that unit that you had in mind. So I'm using PSI, so my stresses are going to come out in PSI, my forces are going to be in pound, and my lengths are going to be in inches. Alright, so OK this. Okay, close this. Material is defined. Our model had 2 cross-section areas, right? Let me show you this again. We had 0.1 here and 0.15 here. So what I'm gonna do is we are gonna need to define 2 sections and label them. So I go here, section. It's gonna be about links, add. So I'm gonna give ID 1, number 1 to my first section. So 1 ID section name 1. The area for that was 0.1. That's gonna be my section 1. Right? Math, I don't need that, so I don't input that. So the only thing we need is the area, and I did that. But I had another one, section number 2. For that one, the area was 0.15, so I do that. So now I have those 2 generated. Okay, so next is my model. I have to start modeling what I had. So create, I'm gonna need key points. The key points in my model, let me open that, is gonna be first point A, point B, and point C. These are the key points in my model. These are where at A and C I have my walls, and point B is where my transition happens from cross-section A to cross-section B. I mean cross-section 1 to cross-section 2. So let's go here and make that model. So we're gonna make 3 key points using our active coordinate system. So I'm gonna click on this. when I say point 1, I'm going to have point A located at coordinate 0, 0, 0. So 0, 0, 0. Apply. That's my first point. It's going to be here. And then my second point, which was point B, was located 10 inches to the right. So coordinate will be 10 inch. So that's point 2. We see that here. And then point 3 is going to be basically 22 inches to the right of my first point. Right? So it's going to be point 3. Alright, so I have 3 points. 1, 2, 3. If you want to see them, you can come here, list key point, coordinates, and attributes. You can list them here. You see point 1 located at coordinate 0, 0, 0. Number 2, point 10, 0, 0, y, and 0, 0. And point number 3 at 22 inches, and then 0 and 0. Yeah, you see them. And then what I'm going to next create lines. So I'm going to connect them to lines. Okay, so create lines, right? A straight line we're going to make from 1 to 2 and then 2 to 3. Yeah, so you saw what I did. Was I clicked on the straight line and then I clicked on point 1 and 2. I made one line. From 2 to 3, I had another line. Again, if you want to see the list of lines, you can see them here. I have 2 lines. Length of line 1, you see that here. Is from connects key point 1 to key point 2. Length is 10 inches. Line number 2 connects key point 2 to key point 3 is 12 inches. Right? So I have 2 lines right now generated. Okay. So we have the lines. Now next we have to mesh them, right? We have to generate mesh, define our, we have our elements generated. We have to mesh them now. This is what we call. Alright, so let's go down. But I have to tell the software that the first line is gonna be meshed with cross-section area of 0.1 inches. 1 inch squared, which is what I called section number 1, and this one must be section number 2. So for that we have to actually specify that. So you have to go to do that. You go to mesh attributes, and then you have to pick line. Let me pick line, and then tell the software. Remember, we have link element active. So I picked that one. And let's say OK. You see our element type that is active in my model is link number, link element. Material is number 1 is going to be used, which is aluminum. I already, I have it in my model. Section number 1 is going to be used. You see I have 2 of them. But I know that this first line, which was AB, right? Segment AB of my model. Let me show you. This one has area of 0.1. So that one is already right. So now we're going to pick the second line. This one, I'm sorry. I'm going to pick the second line now, this line. But for that guy, we have to change the section number to 2, because I know that one area has area of 0.15. So we did that, right? So this one has is a link to my section number 1. This one is linked to section number 2. What else I need to tell? For this model, I don't need many elements. What I want to do, I also want to tell software that I just need one element. One element here and one element here. So to do that, you go here, manual size, meshing, mesh to, size control, and then lines. See that you can, since for both of them I'm gonna do just one section, I can just pick all lines. and say all lines, I just want to have, see number of element divisions, I just want to have one, right? I just want to have one element be generated on each line. So one element here, one element here. Remember, cross section area already assigned, section 1, section 2. Alright, so we did that, and what else? Next step would be applying forces and boundary conditions. Okay. Oh, by the way, yeah, we have not meshed yet. We just said make. We have selected mesh attribute, and we have said that make one mesh here, one element here, one element here. But now we have to mesh it, and it's gonna be meshed based on, you know, see, I'm going to mesh, and I'm gonna mesh all lines, pick all. It's going to be meshed based on what I have asked the software to do. So what I asked to do was do link 180 element to mesh this, and then areas was the right area was associated with them, and also the number of division, number of elements was already determined, indicated to the software. So now that I said meshing, mesh was done. So let's go here and look at our meshes, see what the list of our meshes. I go list of elements, and let's look at that. Nodes and attributes. Let's see what we got. We got just two elements, you see, element 1, element 2. Both of them, they have material 1, and section for element 1, section number 1 is used. For second one, section number 2 is used. And then we have 3 nodes total, 1, 2, 3. Element 1 connects node 1 and 2, and then second element goes from 2 to 3. Alright, so this is what we had. And if you want to see the nodes, list of the nodes, you know, it's going to give me the nodes. We have 3 nodes, as I said. One node is located as 0, 0, 0. The second one is the 1 second key point. The last node is on the third. You know, this is how you can see that. And if you want to plot them, you can plot them too. Look, these are my nodes. I plotted nodes. Let's see, plot control. You can show numbering too. So let me see. I want to see the node numbers. I want to see node numbers. Now you see that. You see that node numbers 1, 2, 3. I have three nodes. You want to see elements? Yes, we have these elements. Let's see. Yeah. All right. So it looks like we have done things right. Yeah. You want to see elements? I showed that already to you guys. List of elements, list of nodes, list of lines. We saw that already. You know, these are. So it looks like we have done everything right. Now we have to put load, right? So analysis type is a static, okay? Define loads. First, I want to fix the left side, the left key point, and the right key point. Let me do that. The left key point, this guy, must be fixed. Right, the left key point is fixed. The right key point, the right wall. You see what I'm doing? I go to key point, click here, okay. All degrees of freedom, I'm gonna say 0. It means that all of those guys be 0. So everything 0. Then we need to find to apply a force. Force on a key point. We could apply it to a key point, or you can apply it to the node. But my force, I'm gonna apply it to this key point at point 2. You know, instead, we can put the key point number here too. You know, I can just say 2. It's gonna be 2.2. Okay. Force in X direction. Right, is in X direction 1,000 pounds. You remember that? Let's go back. You know, see this force, this red thing is shown here. Yeah, see 1,000 pound force goes to the right. Okay. We are done with our model. Now we should solve it. Alright. So next step would be solution. I go here, so you see what I'm doing. I'm gonna go to here to solution, current base, and then done. Solution done. Now let's go see the solution, the results. Alright, so let's see. We can see plot results, list results. Let's see what we have. Okay. I want to first see reactions. So to see reactions, you see here. So list results, reaction solutions. Let me go there. And I'm gonna say you want to see just reactions in X direction, Y direction, or Z direction. You can do that. You want to see moment, or you just want to see forces, all forces. You just want to see all the structural forces. I already know that there is not going to be any reaction in YZ direction. I know that, right? So if I do this, I'm going to get 0. Everything is in X direction. But let's see that. Okay, so all the structural forces in F. Okay, there you go. Already, as I said, I already knew. Okay, node 1, which was my what? Left wall was right key point 1, and I'm gonna have negative 444 x force in x direction, Fy is 0, Fz is 0. Okay, is this matching what we had? That was what I called Ra, right? Yeah, 444.4. And Rc on the right side, node 3, 5555. You know, that one is right too, 555.56. Okay. So these are reactions. We just have two reactions. You have two supports, right? The reactions are going to be given at support. This support and this support, right? And then they are what? These forces. They are matching my results. Okay, that's good. Yeah. So if you want to see, let's see, what else? I'll see nodal solution. I'm interested in seeing how much each node moves to the in X direction. You know what? I know node 1 and node 3, they are supported, their fixed support are gonna be 0 X direction, right? Movement. The only node that is gonna move is this one, number 2. Yeah, so let's see that. So nodal solution, you go here, X component, and then yeah, this is what we have. So node 1, I knew it already, 0, 0, 0. Node 2 is gonna move 0.4 times 10 to negative 2 inches to the right. Why I say right? Because it's positive. Number 3 is 0. Yeah, by the way, from theory I forgot to calculate that. It's not really hard to calculate now. If you look at here, it's, let's do that. You know, node 2 is point B. Alright, if I want to calculate that, let me show you. If you look at member AB with my solution, you got here, member AB. You see that this is like pulling it to the left. So member AB, this end actually is wall. This part is, you know, point B is pulled to the right. With what force? 444.4. So if I want to find how much B goes to the right, it's easy. It's actually PLEA you guys have to use. What is PLEA? 444.4. What was this length? It was 10 divided by multiple velocity was 10 million. 10 million. And then area was 0.1. Okay. So, okay, you see 10 cancels with this 10. This will be this. Cancel this. I'm going to have this 444.4 times 10 to negative 5. Right? Which is basically the same thing. I can write it this way. The solution was this, right? 444 times to 10 to negative 2. Because you have 3 zeros here, yeah. This is how much B goes to the right from theory, which is exactly matching what I have from ANSYS, right? Okay, so that's good, right? Alright, so this is how it works. Link element. That was the most basic element you can use in ANSYS. In other videos, I'm gonna use more advanced elements for other structural models. Alright, I hope you guys find this useful. Alright, so see you next.